Hi, in this class, I'm going to be solving May-June 2023 variant 1 for pure 1. The first question is, solve the equation 4 sine theta plus tangent theta equals to 0, where theta is greater than 0 and less than 180 degree. So the first step is to replace tangent theta with the identity of sine theta upon cos theta. Make the denominators common. You get 4 sine square theta plus sine theta equals to 0. Sorry. First, you make the denominators common. That's going to be cos theta. This is going to be multiplied by cos theta. So that's going to be 4 times sine theta cos theta plus sine theta equals to 0. You cross multiply, you're going to end up getting 4 sine theta cos theta plus sine theta equals to 0. You can take sine theta common. The next bracket would be 4 times cos theta plus 1 equals to 0. Now these are the two factors which are the product of these two factors is equals to 0. So therefore sine theta is equals to 0 and 4 cos theta plus 1 is equal to 0. So cos theta would be equal to negative 1 upon 4. Keep this thing in mind that the value of theta has to be between 0 and 180 degree. So if you find the angle from here, the basic angle is going to be 0 and theta value is going to be 0 and 180 degree. But these values do not fall within the domain, within the range of theta. So you can ignore them. Okay, they won't be part of your solution. Cosine theta is equal to negative 1 upon 4. Cos theta is negative in the second and in the third quadrant. But since the domain is from 0 to 180 degree, that's the only angle that we are interested in. This is the basic angle. So the basic angle is going to be cosine inverse of 1 upon 4. That is 75.52. 180 minus this value, theta comes out to be 104.5 degrees, correct to 1 decimal place. This is the working for question number 1. Please let me know on the chat group if you have any questions. Try solving these questions, this paper with me in the class. Okay, this was the easy one. Moving on to question number 2. Find the first three terms in the expansion in ascending powers of x of 2 plus 3x to the power of 4. 2 plus 3x raised to the power of 4. We need the first three terms. So the first term would be 4c0, 2 to the power of 0, 3x, 2 to the power of 4, 3x to the power of 0, plus 4c1, 2 to the power of 3, 3x to the power of 1, plus 4c2, 2 to the power of 2, 3x to the power of 2. Okay, these are the first three terms. If you evaluate this, 2 raised to the power of 4 is 16. 2 to the power of 3 is 8. 8 times 4 is 8 times 4 times 3 is 96x plus 4c2 into 2 square into 9 would be 216x square. These are the first three terms in the expansion of 2 plus 3x to the power of 4. Now in the second part, you need to find the first three terms in the expansion in the ascending powers of x for 1 minus 2x to the power of 5. Again, the first term is just going to be 1 over here plus 5c1, 1 to the power of 4 minus 2x to the power of 1 plus 5c2, 1 to the power of 3 minus 2x to the power of 2. So the expansion would be 1 minus 10x, 5c2 times 4 is 5c2 is 10, 10 times 4 is 40x square. These were the first two parts. Okay? Now the third part says, hence find the coefficient of x square in the expansion of 2 plus 3x to the power 4 times 1 minus 2x to the power 5. We need to find the coefficient of x square. We have the first three terms. The first three terms for 2 plus 3x to the power 4 are these. And the first three terms for 1 minus 2x to the power 5 is this. We want to multiply these brackets in such a way that we get coefficient of x square. So to find the coefficient of x square, I can multiply 16 with the term in x square, 96x with the term in x, and 216x square with the constant term 1. So 16 times 40x square plus 96x times negative 10x plus 216x square times 1. अब इसको simplify कर लें. Okay. What do we get? 16 times 40 minus 960 plus 216, we get negative 104 x squared. So the coefficient of x square is negative 104. This is the working for question number 2. Okay. Any questions till here? Okay, let's move on. In this question, you have been given two functions and you need to describe fully a sequence of two transformations which maps f of x to g of x. That's your initial function graph. That's your final function. You need to give a sequence of two transformation. Now, obviously, I can see that the size has changed, so definitely enlargement is taking place. Okay. But this enlargement, is it in the vertical parallel to y-axis direction or parallel to x-axis? Is it a vertical stretch or is it a horizontal stretch? We need to figure that out. Okay. First, let's find out the stretch factor. If you look at this line, okay, I can see that the column vector would be 2, 4. The column vector over here is 2, 4. And over here, the column vector is 2, 2. Okay. Let's consider this line. The column vector over here is 2, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. The column vector over here is 2, 1, 2, 3, 4. Okay, so I can see that there isn't any stretch in the horizontal direction. It remains as it is. But there is a stretch in the vertical direction by a factor of 2. So the first transformation is a vertical stretch in y direction with a stretch factor of 2. Okay, you need to describe fully a sequence of two transformation. When you're going to write stretch in the y direction, you're going to get 1 marks. And for describing it, you're going to get the other marks. Now the next transformation. So what will happen if I just stretch this by a stretch factor of 2? Let's see how will the graph look like. If I stretch this point with a stretch factor of 2, there will not be any, see, I'm doing the transformation in the vertical direction, so not in the horizontal direction. So this x coordinate, there won't be any effect on the x coordinate. The only effect is going to be on the y coordinate. So if this point have a coordinate of -1, -3, it's going to, after stretching, it's going to become -1, -6. For this point, it's 1, -1. So after stretching in the y direction with the stretch factor of 2, it's going to be 1, -2. Similarly, this point, after stretching, it's before stretching, this is 3, 3. After stretching, this will become 3, 6. And this is 5, 3. It's going to become 5, 6. So after vertical stretch, after the first transformation, the diagram is going to look like this. Now the size of this and the size of this is same. Now you can see that this graph has now been translated over here. Is it a vertical translation or a horizontal translation? It's just a horizontal translation. There isn't any movement in the y direction, so it's just a horizontal translation. So what is the translation vector? So identify any two corresponding points. 1, -1, -2, -3, -4, -5, -6. So f of x is going towards 6 units towards the left. So you can say translation. The next transformation would be translation, and you can write the translation vector -6, 0. Any questions so far? One is the horizontal translation, the other is the vertical stretch. One is the vertical transformation, the other is a horizontal transformation. So order does not matter. If you would have translated first and then stretch, even then you're going to get the correct graph. Okay. Whenever we have one vertical and one horizontal transformation, order does not matter. Is everyone clear with question number 3? Can I move on? Okay. Question number 4. The diagram shows a sector ABC of a circle with center A and radius is 8. The area of the sector is 16 pi upon 3. So the area of this sector is 16 pi upon 3. The point D lies on the arc BC. Find the perimeter of the segment BCD. So we need to find this arc length and add it with the length BC to get the perimeter. Now, first we need to figure out this angle. We do have the area of the sector. Okay, so area of the sector is given by half times r squared times the angle. Area is 16 pi upon 3. Solving this will get the will give us the value of theta. Okay, so theta comes out to be 16 divided by 3 times 2 divided by 64. That's pi by 6. So we have the value of theta as pi by 6. Now we can find the arc length. Arc AB is going to be r times theta. The radius is 8. The angle is pi by 6. So that's going to be 4 pi upon 3 centimeter. And to calculate the length BC, to calculate this length BC, I can just use, see, this is an isosceles triangle. So if I drop a perpendicular line over here, it's going to bisect the line BC. So this length is half of BC. It's a right angle triangle. Hypotenuse is given. This angle is going to be half of pi by 6, that is pi by 3. Sorry, pi by 12. So we have the angle. We want to find this opposite side. This opposite side is going to be half of BC. So the correct trigonometric ratio that we are going to use is sine pi by 12 equals to half of BC divided by 8. Now you make sure you convert your calculator in radian mode. So sine pi by 12 multiply by 8 times 2. You get BC length as 4.1411. So now the perimeter will be arc BC plus the length BC, 8.33. Okay, that is the working for question number 4. Are we clear till here? Please let me know on the chat box. Do we get it? Can I move on? Okay. Question number 5. The line with equation y equals to kx minus k, where k is a positive constant, is tangent to the curve with the equation y equals to minus half x. So we have a line and we have a curve equation, and the line is tangent to the curve. Find in either order the value of k and the coordinates of the point where the tangent meets the curve. So we need to find two things, the value of k and the coordinates of the point where the tangent meets the curve. 5 marks question. Okay. So firstly, what we are going to do, we are going to equate the two equations. Try to solve this. It's going to be 2kx square minus 2kx equals to -1. 2kx squared minus 2kx plus 1 equals to 0. Now we know that the line is tangent to the curve, so the discriminant of this quadratic equation must be equal to 0. So b squared minus 4 times a times c equals to 0. 4k squared minus 8k equals to 0. Now you can take 4k common, you get k minus 2 equals to 0. So k is 0 and k is 2. Now k is a positive constant, so k cannot be 0. So the correct value of k is 2. When k is 2, we need to find the coordinates of the point where the tangent meets the curve. So it is the intersection point. The intersection point is given by this equation. When we solve the two equations simultaneously, this is the resulting equation. The solutions of this equation will give you the x coordinates of the intersection point. So plug in the value of k in this. So the equation becomes 4x squared minus 4x plus 1 equals to 0. Solve this equation for the value of x. You're going to get x value. You're going to get repeated x value. Okay. So if you solve this, you're going to get repeated roots. Okay. Because it's the case of tangency. You're going to get x equals to half. When x is half, what's going to be y? To find the y coordinate, we're going to plug in x back in either this equation or this equation. Totally your fault. So if you plug it in this equation, you get y equals to minus 1 upon 2x minus 1 upon 2x, and x is 1 upon 2. So y comes out to be negative 1. So the point of intersection, okay, that's going to be half comma negative 1. That's the answer. All right. That's the case. This is the solution for question number 5. If you have any questions, let me know. May, June 2023, variant 1-1. Okay. Understood? All right. Let's move on to question 6. The first three terms of an arithmetic progression are p squared upon 6, 2p minus 6, and p. Given that the common difference of the progression is not 0, find the value of p. So we have the first three terms of the arithmetic progression. To formulate an equation, we are going to use this concept that the arithmetic progression has a common difference. So common difference is the second term minus the first term, which is same as the third term minus the second term. So you get an equation in terms of p, you solve it, simplify it, and solve it. So 12p, you make the denominators common, 36 minus p squared, p minus 2p plus 6. 6, okay. Minus p times 6 is minus 6p plus 36. So p squared minus 24p, sorry, minus 18p plus 36 plus 36, that's going to be plus 72. So we have an equation in terms of p. We're going to solve for the value of p. So after solving this, what value of p do we get? One value is 12 and the other value is 6. Okay. So we need to pick up the, it just says value of p. So one of the value is going to be correct and the other value is not going to be correct. Okay. So the question said that the common difference of the progression is not 0. So if we take 6, okay, the first term is going to be 6 squared 36 upon 6, that is 6. The second term is going to be 2 times 6, 12, 12 minus 6 is 6. So the common difference is going to be 0. Okay, and the third term p is 6. So the common difference is 0, and we don't want the common difference 0. So we are going to neglect this value. So the only solution of p is going to be 6. P is going to be 12. Okay. Is everyone clear with part A? So the correct value of p is going to be 12. All right. Moving on. Now the part B says, using this value of P, find the sum to infinity of the geometric progression with the first two terms P square upon 6 and 2P minus 6. So we need to use this value of P, but this time the progression is geometric. So the first term is P square upon 6, that is 12 square divided by 6, which is 24. And 2 times 12 minus 6, that's 18, and so on. So we know that the first term of this progression is 24. The common ratio is going to be 18 divided by 24, that's 3 upon 4. Okay, so we need to find the sum to infinity. Sum to infinity is a upon 1 minus r. The first term is 24. The common ratio is 3 upon 4. So 1 minus 3 upon 4 is 1 upon 4. 24 divided by 1 upon 4 is going to be 24 times 4, which is 96. All right. Are we clear with question number 6? Okay. Then we have question number 7. A curve has equation y equals to 2 plus 3 sine half x. The domain given is from 0 to 4 pi. We need to find the greatest and the least value of the function. Now, please remember that whether it is sine x or whether it is sine half x. Sine half x is just a horizontal stretch. Okay. It doesn't affect the range. So since sine x is between -1 and 1, sine half x is also between -1 and 1. So y equals to 2 plus 3. For sine half x, you can plug in -1. And for sine half x, you can plug in 1. After plugging -1, we get 2 minus 3, that's -1. And this is 5. So that's the least value of y. And that's the greatest value of y. Okay. Now, in the second part, we need to sketch the graph. Okay. So for sketching, we now know the minimum and the maximum value. The minimum value is -1. The maximum value is 5. So the axis of rotation is going to be between 5 and -1. So 5 minus 1 divided by 2. Okay, you add these two values and divide by 2. So that's going to be 2. So the axis of rotation is going to be at 2. Okay. Now, how many cycles do we have? We will have this half x means that is going to be half a cycle in 2 pi. So one complete cycle is going to be in 4 pi. So we are just going to draw one complete cycle in from 0 to 4 pi. Okay, this is 5, this is 2, this is -1. And so half cycle in 2 pi. So quarter cycle in pi. Okay, joining these points will give us our curve. That's one cycle of, this is the function y equals to 2 plus 3 sine half x. Any question regarding the sketch? Please ask. Okay. The last part says state the number of solutions of the equation 2 plus 3 sine half x equals to 5 minus 2x. So guys, this is the curve that you have already drawn in the above sketch, 2 plus 3 sine half x. This represents the line. So I need to sketch the line and then figure out the number of solution. So the line equation is y equals to 5 minus 2x. So when x is 0, y is 5. And when y is 0, okay, let's take another value. Let's take 2 pi. Okay. Let's take 2 pi. So when x is 2 pi, we get negative 7 point something. So clearly it's going to be a sketch down. Or we can find the x-intercept as well. X-intercept is going to be 5 upon 2. That's going to be 2.5. And 2.5 is a value before pi. So that's the line. Okay. Now, how many point of intersection do you observe? Just one. So the number of solutions is just going to be 1. That's the entire question for question 7. Okay. Question number 8. The functions f and g are defined as follows, where a and b are constants. Function f is given in terms of a, 1 plus 2a upon x minus a. It's defined for x greater than a. Function g is bx minus 2 and x belongs to all real values. Given that f of 7 is 5 upon 2 and g f of 5 is 4, find the values of a and b. So just plug in the values. F of 7 means in place of x, plug in 7 and equate the result to 5 upon 2. Okay. That's the first equation. G f of 5 would mean that insert the value of f of 5 in function g. Okay. So function g is b times x minus 2. And in place of x, you're going to insert function f. And in the function f, you're going to plug in x as 5. And the result is going to be equal to 4. So we get two equations, we solve them simultaneously and figure out the values of a and b. From the first equation, I can easily get the value of a. So I get a as 3. When a is 3, let's figure out what b would be. 1 plus 6 upon 2. That's 4b equals to 6. And b comes out to be 6 upon 4. That's 3 upon 2. So we have the values of a and b. So it was just a question on solving simultaneously. Now, the second part says, for the rest of this question, you should use the value of a which you found in part A. Part A, we found the value of a as 3. So this means that the function f of x would be 1 plus 6 upon x minus 3. And the domain is going to be x greater than 3. Since it was x greater than a, and a value is 3, so the domain is going to be x greater than 3. Now the question says, find the domain of the inverse function of f. Without actually finding the inverse function, we just have to find the domain of the inverse function. Now the domain of the inverse function, guys, is the same as the range of the function. So tell me, as x approaches 3, where does your function approach? When you plug in 3 over here, okay, when you plug in 3, that goes to, the denominator becomes 0, the function becomes undefined, or you can say it approaches to an infinitely large value. Adding 1 will give you an infinitely large value. And as x approaches an infinitely large value, because the domain is x greater than 3, how much greater? Up till infinity. So when this becomes infinity, the denominator becomes infinity, the fraction gets closer to 0, and the function gets closer to 1. So f of x approaches 1. So when you increase the value of x to infinity, it approaches 1. When you decrease the value of x towards 3, it approaches to infinity. So the range of f of x should be greater than 1. If f of x is greater than 1, then the domain of f must be greater than 1 as well. The domain of the f inverse function should be greater than 1 as well. Okay, that's the working for part B. Now in the third part, we need to find the expression for the inverse function. Okay, f inverse. So we have the function f of x is 1 plus 6 upon x minus 3. The domain was x greater than 3. Finding the inverse function would require to replace f of x with y. Remember, you need to make x the subject. Okay, so 6 upon x minus 3 equals to y minus 1. X minus 3 equals to 6 upon y minus 1. X equals to 6 upon y minus 1 plus 3. Last step, replace x and y. Okay, so f inverse of x would be 3 plus 6 upon x minus 1. That's the inverse function. Any questions still here? All good till here? Okay. Let me know on the chat box if you have any questions. I'll stop and explain it to you. Question number 9. Water is poured into the tank at a constant rate of 500 centimeter cube per second. Guys, this is dV by dt. 500 centimeter cube per second. The depth of the water in the tank t second after filling start is 8 centimeter. When the depth of the water in the tank is 8 centimeter, the volume V of the water in the tank is given by this formula. The formula is V equals to 4 upon 3, 25 plus h cube minus 62,500 upon 3. We need to find the rate at which h is increasing, that is dH by dt, at the instant when h is 10. So we will be needing to apply chain rule over here to find dH by dt. This is going to be equal to dH by dV times dV by dt. We have this rate with us. We just have to differentiate V with respect to H and then reciprocate it. So let's find dV by dH. dV by dH would be 4 times 25 plus h square. And the derivative of this constant number would just be 0. That is your derivative. Okay. Now, dH by dV is just going to be the reciprocal. We need to find dH by dV at the instant when h is 10. So that's going to be 35 square. This is 1 upon 4900. 1 upon 4900 times dV by dt. So I get positive 0.102 centimeter per second. That is my rate dH by dt. Please let me know if you have any questions in the first part. Okay, all great till here. Part B, at another instant, the rate at which h is increasing is 0.075. So dH by dt is 0.075 centimeter per second. dH by dt is given and we need to find the value of V at this instant. Okay, so if we have dH by dt, okay, and dV by dt will remain same, that is 500 centimeter cube per second. We need to figure out the value of h then. Okay, so how can we figure out the value of h? By first finding dV by dH. So dV by dH is going to be equal to dV by dt times dt by dH. dV by dt is 500. dH by dt would be 1 upon 0.075. 500 divided by 0.075. That's going to be 20,000 upon 3 to be exact. dV by dH expression was 4 times 25 plus h square. So 4 times 25 plus h square is equal to 20,000 upon 3. Solve for h. So 20,000 upon 3 divided by 4, taking the square root and minus 25. So h comes out to be 15.824. Now at this instant, what is the volume? So we are going to use the original function of the volume. The original function of the volume was this. So plug in h as 15.8 over here in this function, plus 25 cube multiplied by 4 divided by 3 minus 62,500 divided by 3. You get 69,888.508. Three significant figure, 69,000 centimeter cube. This is the working for part B, guys. Please let me know if you have any questions till here. Okay, fair enough. Moving on. Question number 10. The diagram shows part of the curve with the equation y equals to 4 upon 2x minus 1 square and the part of the line x equals to 1 and y equals to 1. This is the line x equals to 1. This is the line y equals to 1. The curve passes through the points A, B. Find the exact volume generated when the shaded region is rotated through 360° about the x-axis. 360° about the x-axis, and we need to find the exact volume. Okay, so the starting limit is 1 and the ending limit is 3 upon 2. Okay, now here is the thing. When we rotate the area under the curve 360°, it's going to give us the volume generated by this entire region. But we do not want the volume when this entire region is rotated. We want the volume when the shaded region is rotated. So you see this rectangle over here. When this rectangle is rotated, it's going to create a cylinder. So you have to minus the volume of the cylinder at the end. So first we are going to calculate the volume of the revolution. Volume when area under the curve is rotated. That's going to be pi times integral of the function squared dx. The limit is going to be from 1 to 3 upon 2. Okay, first I simplify the function. This is going to be 16 upon 2x minus 1 to the power 4, which I can write as 16 times 2x minus 1 to the power of negative 4. Now let's integrate the function. 2x minus 1 to the power of minus 4 plus 1 divided by the new power times the derivative of the inside bracket. The limit is from 1 to 3 upon 2. Okay. Now you can calculate this. First calculate the value at the upper integral, upper limit, then calculate the value at the lower integral and then take the difference. So when I do that, I get 7 upon 3 pi as the answer. Okay. Now comes the volume of the cylinder. When this region is rotated 360° about the x-axis, it's going to create a cylinder. And the volume of the cylinder would be pi r square h. The radius of the cylinder is this value, which is 1. And the height of the cylinder is 3 upon 2 minus 1. So pi r square h, that's just going to be 3 upon 2 minus 1, that's half. So at the end, you get pi upon 2. So volume of revolution, the required volume, would be 7 pi upon 3 minus pi upon 2. that is 11 pi upon 6. Okay, guys, this is the working for this question, for this part. So that's the exact volume. Whenever they say exact, the answer has to be either in the form of surds or either in the form of pi. You do not give the answer as a decimal value. Okay. Part B, a triangle is formed from the tangent to the curve at B, the normal to the curve at B, and the x-axis. So there are three lines, the tangent to the curve at B, the normal to the curve at B, and the x-axis. So let's draw this triangle. The tangent to the curve at B, the normal to the curve at B, okay, and the x-axis. So that's the triangle they are referring to. Now, we need to find the area of the triangle. To find the area of the triangle, I need area of the triangle is going to be half times base times height. For the base, I'll be needing these 2 points so that I can calculate this distance. Now, this is the intersection point of the normal line with the x-axis. This is the intersection point of the tangent line with the x-axis. And we already know this point, so I know the height of the triangle. But I'll be needing these 2 points to calculate the base of the triangle. So for that, I'll be needing the equations of the tangents and the equation of the normal. So we will have to differentiate the function y was equal to 4 upon 2x minus 1 square. Okay, let's find dy by dx. That's going to be minus 8 times 2x minus 1 to the power of minus 3 times 2, which is minus 16 divided by 2x minus 1 cube. Now I will be calculating the gradient at point B. So point B k x coordinates are 3 upon 2. So plug in 3 upon 2. So I get minus 2 as the gradient. Okay, so this is the gradient of the tangent line. So the gradient of the normal line would just be 1 upon 2. Okay. The equation of the tangent would be y minus y1, which is the y coordinate of point B, m times x minus x1. This is going to be y minus 1 equals to half times x minus x1. Now we need to find the points on the x-axis where y is 0. So just substitute y as 0 and solve this equation. So one of the value of x comes out to be 2. So x comes out to be minus half. Okay. So this point shall be minus half. I'll represent it on the diagram. This is the x-axis. This was the tangent line. This is point B. This point is 2. The normal line intersects at minus half. This is 3 upon 2 comma 1. So the height is 1. And this distance is going to be 2 minus half. That's 5 upon 2. So the area of the triangle would be half times base, जो कि है 5 upon 2, times height, that is 1. So at the end, we get 5 upon 4 units square as the area. Please check this working and let me know if you have any questions till here. Any problem till here? Anyone would like to discuss anything, please let me know. Okay, last question then. The equation of a curve is such that dy by dx expression is given, where a is a positive constant. The curve has a stationary value at a comma minus 15. We need to find the value of a. Okay, so we know that the stationary point occurs at x equals to a. So dy by dx would be equal to 0 and x value would be plug in as a. 6a square minus 30a plus 6a is minus 24a. 6a common taken common out, so it's going to be a minus 6, a minus 4. So one value of a is 0 and the other value of a is 4, but a is a positive constant, so a equals to 4 only. Okay. Part B says determine the nature of the stationary point. So for that, we have to differentiate the dy by dx function again. So differentiation of 6x squared would be 12x. Differentiation of minus 30x would be minus 30. And differentiation of 6a, which is just a constant number, would be 0. And the stationary value occurs at a, which is a is 4. So we need to find the second derivative at the value of x equals to 4. So when you plug in 4, you get a positive value. 4 times 12 would be 48. 48 minus 30 would be 18, which is greater than 0. Since the second derivative is 0, the stationary point is minimum. Okay. The last part is to find, the second last part is to find the equation of the curve. To find the equation of the curve, we are going to integrate this function. So dy by dx is 6x squared minus 30x plus 6a, and a value was 4, so that's going to be 24. Now you are going to integrate the function to get y 6x cube upon 3 minus 30x square upon 2 plus 24x plus c. अब आपके पास पॉइंट कौन सा गिवन है ऑलरेडी? आपके पास पॉइंट गिवन है a comma minus 15 on the curve. So a comma minus 15 means 4 comma minus 15. Just plug in these values. So when y is minus 15, x is 4. And we are going to solve for the value of c. ठीक है, तो देखते हैं c की वैल्यू क्या आती है. C comes out to be 1. Therefore, the equation of the curve is 2x cubed minus 15x squared plus 24x plus 1. That was the equation of the curve. Now the part D says find the coordinates of any other stationary point on the curve. So dy by dx, okay, dy by dx expression is 6x squared minus 30x plus 24. You're going to equate it to 0 and solve this quadratic equation. You're going to get two values of x. One value of x is 4, the other value is 1. तो हमें एक stationary point 4 वाला तो already पता था. So the other stationary point is going to be x equals to 1. And when x is 1, y is going to be that's 12. So 1 comma 12 is the other stationary point. ठीक है, तो ये हो गया question complete. अब there's a last question 12 related to circle. The diagram shows a circle P with center 0, 2. So circle P has a center 0, 2. And the radius is 10. So your distance पूरा 10 है. And the tangent to the circle at the point A with the coordinates A के coordinates in 6, 10. It also shows a second circle with center at the point where the tangent meets the y-axis. So that's the center of the second circle Q. And the radius is 5 upon 2 root 5. Okay. Write down the equation of the circle P. P की equation, like it's just a 1 mark question. The center is 0, 2. So x minus 0 the whole thing square plus y minus 2 the whole thing square equals to r square और उसका radius था 10, so that's going to be 100. So x square plus y minus 2 square equals to 100. Okay. Now part B, find the equation of the tangent to the circle P at A. So we need to find the equation of the tangent to the circle P at A. To find the equation of the tangent, we need the gradient of the tangent. तो अगर हमें ये पता है कि radius and the tangent are at 90 degree, so if we just find the gradient of gradient of this line, the gradient of the radius line would be y2 minus y1 over x2 minus x1. That's 8 upon 6, which is 4 upon 3. So the gradient of the tangent line would be minus 3 upon 4. और वो पॉइंट ए से पास कर रही है, whose coordinates are 6, 10. So y minus y1 equals to m x minus x1. ठीक है, अब इसको सॉल्व करते हैं. 4y minus 40 equals to minus 3x plus 18. 4y plus 3x equals to 40 plus 18. That shall be 40 plus 18. That shall be 58. ठीक है. Okay, that's the equation of the tangent. Now, part C says, find the equation of the circle Q and hence verify that the y coordinates of both of the points of the intersection of the two circles are 11. So we need to find the equation of the circle Q. अब ये जो tangent line है वो y axis पे से पास हो रही है और जो ये y axis वाला पॉइंट है ये इस सर्कल का सेंटर है. सो इसके कोऑर्डिनेट्स फाइंड करने के लिए मुझे इसकी इक्वेशन में y की वैल्यू को 0 x की वैल्यू को 0 प्लग इन करना पड़ेगा. सो दैट्स द इक्वेशन. 4y plus 3x equals to 58. इसमें मुझे x को 0 प्लग इन करना होगा and the y value comes out to be 58 upon 4, that's 29 upon 2. तो सर्कल Q के जो सेंटर हुए के कोऑर्डिनेट्स हैं वो है 0, 29 upon 2. रेडियस जो है वो गिवन था क्वेश्चन में, दैट इज 5√5 upon 2. 5√5 upon 2. ठीक है, तो इक्वेशन हो जाएगी x स्क्वायर प्लस y माइनस 29 अपॉन 2 द होल थिंग स्क्वायर इक्वल्स टू 5√5 अपॉन 2 द होल थिंग स्क्वायर. 5√5 द होल थिंग स्क्वायर इज 125 अपॉन 4. सही है, तो ये आपके पास इक्वेशन ऑफ सर्कल Q आ गई. नाउ वी नीड टू वेरीफाई दैट द y कोऑर्डिनेट्स ऑफ बोथ of the points of intersection of the two circles are 11. मुझे ये वेरीफाई करना है कि y कोऑर्डिनेट दोनों सर्कल का 11 है. सही है, अब वेरीफाई करने के लिए आपके पास क्योंकि दोनों इक्वेशंस आ चुकी हैं, आप दोनों इक्वेशंस में हाँ, अगर मुझे x कोऑर्डिनेट पता होता, ठीक है, अगर मुझे x कोऑर्डिनेट पता होगा तो मैं फिगर आउट कर सकता हूँ. ठीक है, तो अब उसका तरीका क्या है करने का. अगर आप किसी भी एक इक्वेशन में इफ यू प्लग इन let's say y as 11, you're going to get the x coordinate and that x coordinate in the second circle equation should also give you 11. तब जाके ये verify हो जाएगा. ठीक है, so what I'll do is I'll use the simple equation. The simple equation is this. For equation of the circle P, x square plus y minus 2 the whole thing square equals to 100. x square plus, sorry, यहाँ पे वर्किंग करनी है. एक्स स्क्वायर प्लस वाई माइनस 2 द होल थिंग स्क्वायर इक्वल्स टू 100. अब मैं ये कह रहा हूँ कि मुझे वेरीफाई करना है ना, तो I'll use y coordinate as 11 and solve for x. So if I do that, 11 minus 2 is 9, so 100 minus 81, x square would be 19, x would be plus minus square root 90. ठीक है, now I have the x coordinates, दो x coordinates हैं, which means that this is minus root 19 and this is plus root 19. ठीक है, so in the second equation, which is the equation of the circle Q, अगर हम root 19 प्लग इन करें और y के लिए सॉल्व करें तो हमारे पास आंसर 11 आना चाहिए है. ठीक है, so 125 upon 4 minus 19 that's 49 upon 4, taking the square root. So 49 upon 4 plus square root is 7 upon 2. 7 upon 2 plus 29 upon 2, and y equals to minus 7 upon 2 plus 29 upon 2. So ये तो 11 आ रहा है। अच्छा, एक्स स्क्वायर की वैल्यू ही 19 लेनी है हमने, ठीक है, और फिर y के लिए सॉल्व करना है हमें। तो y की वैल्यू 11 आनी चाहिए, तो ये y की वैल्यू 11 यहाँ पे आ रही है। ओके, so instead of taking plus minus, I should have just used x square equals to 19, and यहाँ पे हम x square की वैल्यू ही प्लग इन कर देंगे, that is 19, and then solve for y, so we get y as 11। तो ये हो गया verify, ठीक है। And the last part, find the coordinates of the point of intersection of the tangent and circle Q, giving the answer in the third form। तो tangent and intersection point of the tangent and the circle Q, तो अब इन दोनों इक्वेशंस को साइमल्टेनियसली सॉल्व करना होगा, ठीक है। तो आपके पास इक्वेशन ऑफ टेंजेंट क्या है? इक्वेशन ऑफ टेंजेंट है 4y प्लस 3x इक्वल्स टू 58। 4y प्लस 3x इक्वल्स टू 58, और आपके पास इक्वेशन ऑफ सर्कल Q आई थी एक्स स्क्वायर प्लस वाई स्क्वायर, एक्स स्क्वायर प्लस वाई माइनस 29 अपॉन 2 स्क्वायर इक्वल्स टू 125 अपॉन 4। आपको इन दोनों इक्वेशंस को साइमल्टेनियसली सॉल्व करना है। इक्वेशन 1, इक्वेशन 2, लेट्स सॉल्व देम साइमल्टेनियसली, ठीक है। पहली इक्वेशन में से इफ यू मेक y द सब्जेक्ट, आपके पास आएगा -3x प्लस 29 अपॉन 2, so -3x upon 4 plus 29 upon 2 minus 29 upon 2, the whole thing square equals to 125 upon 4। You cancel this out, x square plus 9 upon 16 x square equals to 125 upon 4। Solving this will give you 25 upon 16 x square equals to 125 upon 4। So x square की वैल्यू आ जाएगी 20। So x की वैल्यू आ जाएगी स्क्वायर रूट ऑफ 20। स्क्वायर रूट ऑफ 20 इज प्लस माइनस 2√5। अच्छा, अब जब x की वैल्यू +2√5 है तो y की वैल्यू क्या होगी, और जब -2√5 है तो y की वैल्यू क्या होगी? लेट्स फिगर इट आउट। उसके लिए आप कोई भी इक्वेशन में प्लग इन कर दो। यू कैन यूज दिस इक्वेशन, y इक्वल्स टू -3x अपॉन 4 प्लस 29 अपॉन 2, सो -6√5 अपॉन 4 प्लस 29 अपॉन 2। चेक कर लो क्या एग्जैक्ट कोऑर्डिनेट्स में मांगा है। गिवन द आंसर इन द सर्ट फॉर्म, यस एग्जैक्ट कोऑर्डिनेट्स हैं, तो इसको हम एज इट इज रहने देंगे, ठीक है। जहां तक सिंप्लीफाई हो सकता है वहां तक कर देते हैं। ठीक है, सो आई एम गेटिंग 29 -3√5 अपॉन 2, और इसको प्लग इन करने के बाद इट्स गोइंग टू बी 6√5 अपॉन 4 प्लस 29 अपॉन 2, which is going to be 29 plus 3√5 upon 2। ओके, सो ये कोऑर्डिनेट्स हैं आपके पास 2√5 कॉमा 29 माइनस 3√5 अपॉन 2, एंड 2√5 कॉमा 29 प्लस 3√5 अपॉन 2। दैट्स योर आंसर। ओके, प्लीज लेट मी नो इफ यू हैव एनी क्वेश्चंस। ऑलराइट, दैट्स इट फॉर टुडे, थैंक यू।